1, 2, 3. Okay, good evening everyone. Let me adjust this audio level a little. So tonight I'm going to be working on a network monitoring tool. It's not going to do much of monitoring, but it's going to make a fancy graph in real time. So it's going to draw a real-time graph of the network activity, and I'm hoping that we will be able to observe some interesting behaviors, such as, you know, running a speed test and then seeing, oh, does the graph spike up, or, you know, maybe mute the audio on the live stream and see if network usage goes down, that sort of thing. Even though I think that's supposed to be pretty fixed. So I'm planning to do it in just C, because why not? I can always learn more details about using C. So let me just switch to my workspace and start a project, see how it goes. Right, we're back. Everything seems good. Okay. So let me go to my project folder and make a directory called C network graph. Should be good. Right, how to begin? Well, always good to have a main file and a make file, of course. And what else? Well, nothing else is needed so far. So, as always, let's start with a nice and simple hello world. Right, what are the usual flags? Warnings, extra warnings, you know, we want pedantic warnings. They should be good. Maybe a little more. I don't know. Right, and it's gonna output main from main.c. Set our usual formatting stuff as well, just to get it out of the way. Should be some here. Let me just copy paste that. Okay. And we're met with hello world, so that's a good start. So here's the plan. I'm planning to use most likely SDL for rendering, and gonna make a sub process to, I don't know, tshark maybe, to capture network activity. Let's actually see how that works, or if that works. Okay, so it's showing me that all my data is right now going through WireGuard, which is because I'm using a VPN right now. But the important thing here is how many packets we have, and at the end there's data length, which, you know, should indicate that, you know, this is like a 64 byte package, that's a 1400 byte package, and so on. And, you know, we should be able to use that essentially to add those values over time, maybe cut off within some interval, and just plot that on a chart. No, I want to see the exact output format of tshark, so of course we can use something like, what's that called? Yeah, like a pcap file, but don't want to bother parsing that, so just gonna use the outputs directly. Right, so we can use -o to format the output. Now that's great. That's very, very helpful. So let's try that. -o, and what did we pass? Some sort of pseudo JSON shit. I think when it says output format and when I say output format, we mean two different things. Let's see. Okay. So just IP packets should actually do the trick for us. So let me try -t fields. Right. And IP. Okay, now this displays source and destination packets for IP headers. IP.proto. Right, what I need is tshark expressions, really. Expressions. Is there man pages for this? Man tshark. No, that's not very useful. This is also not very useful. There was a really nice documentation website here. Protocols, logic, all of that, all of the cool stuff is here, but really all I want is like what fields are there. So maybe capture formats. No, it's definitely not it. P.dst. No, maybe just dst. Script packets. Damn it, that's really difficult to find the thing I need in all of this documentation. Maybe this will help. Scripting, contexts. No, just need filter format. Like seriously, this should not be a difficult thing. Capture filters, there we go. Capture versus display filters. Right. Well, display filters might be closer to what we want. Sorry, I'm just gonna close the window. It's too fucking loud outside. Right, let me just position myself in front of the mic and should be good. Right, okay, where were we? Yeah, display filters. Now, could do some guesswork, like IP.size. No, some filters aren't valid. Well then, tell me what are valid filters. tshark help filter, nope, let's grab that instead. And right, what's dash T? Let's find out first. Right, dash T really doesn't say. Let's give some context. Jesus Christ, stupid crap. Right, format of text output. Fields. Right, if only there was a way to list all the fields that are available. Field. Set options for the fields. What about JSON outputs? That might be way better. Right, that includes the whole packets, and I really don't want to deal with that. So, what else? JSON raw, EK, tabs, maybe interesting. Right. IP. Data len is not valid. Let me just, start up Wireshark here. And I don't have Wireshark? No, there it is. Let's use Wireshark to kind of discover these filters a little. IP dot. Well, let's do that. And let's see. It has time to live and total length. There we go. It says it's just .len, so let's try that. Oh, there we go. Now this is all we need, but I'd like to have the timestamp there as well. So timestamp, maybe? Timestamp is not valid. Time is valid, but it's displaying literally nothing. Could be trying to decode everything as like network time protocol, perhaps. Let's see. tshark filter timestamp. Frame.time. Perfect. So, oh, that's not very convenient. That's really not very convenient for me, but let's jump back to Wireshark and try to see if there's any other cool things in Frame. So, right, this time thing here is what I want. So that's Frame, what we used before. And time since reference or first frame. That's really what I want here. So time underscore relative, it seems, is what I need to use. So let's do that. Time relative. And now this output is perfect. This is exactly what we need. And now we can start doing things. Right. So I'm gonna have certain assumptions about this, like the timestamp between two packets never goes backwards, this sort of thing. It's not gonna break anything if these assumptions are broken, but you know, it's gonna make it a lot easier to reason about how we structure everything here. So let's see. Right, what I'm gonna do is there's going to be an interval essentially about how often we sample, and what the program's gonna do is, let's say we do it once a second, it's gonna wait until the next relative seconds, add up all the total length of IP packets we get, and then just plot that. And probably since we're going to be forking into a child process, that's going to send it over with a pipe, either send all the raw data or just, you know, send it once the interval passes, like every second, every half second, that sort of thing. And then the main threads will handle rendering the graphics with SDL. Let me see if I can adjust that a little. It might be better. Although not really. Let's see. Just gonna crop this a tiny bit from the left, because you know we really don't need this screen there. It should be much better. Right. So by the way, I've never used like a, you know, pipe in C, so that should be interesting. Let me just open this bad boy. Right, I was already looking this up just a tiny bit, so it looks rather simple. You get two pipes, like two integers essentially, when you call pipe, and then after you fork, the child uses one of the pipes and the parent uses the other to just communicate with each other. This is just like channels in Rust or Golang. Let's see. Yeah, let's try that. So I could even call it channel, to be honest. Right. Here's another thing though, these channels are really two-way rather than one-way, and I'm thinking I might actually use, you know, both ways, but just for the sake of making the API simpler, I'm just gonna keep them one way, and then have two channels, one for like configuring the child if we ever have something like that, and the other for the other one for sending back data from the child to the parents. Right, we might have dropped for like half a second there. I hope that didn't affect anything. Let's see. So let's see how pipe really works. Yeah, it actually takes something like two integers, like an array with 2 integers. So file descriptors. Let's include also uni_std here. And so the API I have in mind for this is, let's see, could send byte slices, could just send pointers. Yeah, why not? We could send buffers directly, and it's just gonna have let's see, channel creates. So that's gonna basically return channel C dot. So that's gonna return that channel after it sets it up, and I'm gonna have channel send and channel receive essentially. And let's see, channel receive, we probably want to do that with select, just so we don't block anything. And well, yeah, I think so. So we might not actually want to use like a convenient API like this because, well, no, because right, let's think. Because we could just like pass this channel file descriptor into select, and then it will just work out of the box. So so it takes a pointer and a length, and oh, of course, sorry. Of course, it takes a channel as well. So let's do that. And there's gonna be a channel receive. Now, this is more interesting. We need to kind of pass like a sized buffer in there, but for my use case, we're really gonna use like fixed size buffers. So like it's not gonna be doing like partial reads or anything like that. Essentially everything is gonna be available once it's sent. So let's do the same here. So as a pointer and a length, but the length is really gonna be available in compile time, so there shouldn't be any like safety issues or anything with that. Channel creates, does that. Yeah, so we call pipe, give the file descriptors, and the return value is whether or not this was successful. So we should really assert that. So let's call pipe and pass here the file descriptors from the channel. Actually, I'm not going to keep that in the channel. I'm just going to keep them separately. So file descriptors. Let's just keep them like this. And also just going to quickly modify my makefile to do, compile in ANSI C instead of, cool guy C. see if everything still builds. That's fine. It's gonna have 2 members, of course. So file descriptors, just pass that. And we're gonna assert that this is equal to 0 and that there were no errors. So let's try channel C and channel create. Let's create a channel. Everything seems to compile. Struct has no members, whatever will be fixed. So we created 2 ends of the pipe. Now what we want to do is, I guess we really decide which end is the read end and which one is the write end of this pipe. So we'll just going with the analogy of standard input and standard output. Let's see. I really shouldn't be forgetting this thing this often. Right, so standard input is 0 and standard output is 1. So when we write into the channel, we want to write it into 1. Right. Oh. Right, do I really want to have 2 sides of this? So we write into 1 here. But, right, it of course depends on which process is doing the reading or writing. Because, well, of course, no, it reads from 0 here, and this one writes to 1. So, right, we can't really close anything, so we're just gonna have to. We'll do the closing and opening parts once we create the tasks. So let me just call these open and close, read and write. Sorry. Read FD and int write FD. And read FD is gonna be file descriptor 0. And write FD is gonna be file descriptors 1. And that should work. So here we've created the channel. Really sending and receiving is just a read or write call. I don't even know if it's worth keeping these channel structs and like this channel API around. I don't think it's worth keeping around. So. Or we could keep that around, but get rid of like send and receive and just use read and write. You know, like C++ would make this really convenient because we could use templates, read a certain amount of bytes, and write a certain amount of bytes with like a, you know, template type. But this is C, and we do that manually, and it's really inconvenient, especially for this kind of API. Let's see. I suppose as a test we could just send one value and then that'll be it. Yeah. So for that we're gonna do right, or actually, should it not be F right? Pipe right versus F right. Well, F right will buffer a little, but also it's able to read and write like complete structures, while write might do partial writes. Let's see, efficient. Well, let's just check POSIX documentation. See if it has any examples on using pipes. So, close, create an inter-process channel. This is what we want. P open shall execute the command. Right. Let's think. We could use popen. So it takes a command and returns a file pointer. And it... Huh. That's kind of cool. Why don't we do that? Well, one reason is I'd really like to offload the processing of tshark output to a separate thread, and if we're gonna do that anyway, there might not be too much benefit, although no, we could still process it in another thread but use popen anyway. Let's use popen. You know what, I decided as the sole authority here that we're gonna be using that. So, well, we don't even need to include anything. How cool is that? Right, so time to create this child process. That's in UniSTD, which we already included, and returns a PID-T. Right. Fork PID, and we'll just do that. Let's also print that and see what happens. Rapidity is undeclared. I think that's in like sys types, right? Sys types. Should work now. Well, that didn't work because, yeah, passed the wrong thing, basically. Right, there we go. So it executes everything twice because, of course, it essentially splits into two tasks at that point. And we have the child's process ID and the parent's process ID. And that's really all we need at this point. So we can split off here. Let's see, this is the child. And we can do that. And of course, we can also do this. And nice. And we can only make, for example, the child say hello world. And there we go. Parent, child, hello world. It all works. All works without any problems. So now we could split off these things, like the logic of the parent and the child, into their respective functions. Right, so I'm gonna return int, just like, you know, because it's gonna be the return code of that process, even though the parent might not care about it. So handle child and handle parents. And now we won't actually need the process ID for anything, so that's fine. I'm just gonna do return handle child here, and let's move everything we were doing there before, just so the output is the same. Return handle parents here. We can just pass the channel as like a static variable, like a global, essentially. That did not work well. Of course not, because we don't keep that around anymore. So let's change that to puts, and also here change it to puts. And everything should still be working. Right, there we go. Everything works, and that's good. Let's see. No. Here's the other thing we're gonna be doing. We're gonna do a file pointer here to tshark, right? Popen, and let's see what this takes. A mode, and you know, we're not really going to be writing anything to tshark, so it could just be R. This is the commands. This is R, just because we're purely reading. And here's the command we will be executing. So let's paste that right here. Now, what we want is, okay, let's start simple. Very, very simple. Ideally, I would be able to change the interval and the speed of the graph so it groups more or groups less, but let's hard code it for now. Right. Interval, and that's gonna be, let's say, 1.0, because yeah, that'll be nice and easy. We'll be able to follow it with our eyes, and it will actually have some meaningful data instead of, you know, absolutely nothing. So the child is gonna be, so both the parent and child are gonna be in essentially loops. Now I don't know what happens when the parent terminates. Does the child stay behind? Who knows? So let's quickly test that. Right. So by this point, the parent should be completely done. So it means the child does really stay behind. So we need to exit, right? Wait null waits for a child process to exit. What if I don't want to wait? Could I call simply exits from the parents? Balls. Of course that doesn't die. Shit. Yep, nothing's gonna fix that, I guess. Let's kill it with... no, not you, OBS. Is it gone? Yep. Right, so handling exits, very important, apparently. So what I can do here is, instead of return, I could exit with it. And at the end, let's just put return here. Return 1. Just so we know. And if the child is gone, do we care? We don't really care. So do we want to exit though? Definitely. Definitely want to exit also. And now, well, that sucks. Then we know exit doesn't work. Right. Pkill main. Let's see if that works. Nope. How about this? There we go. That worked. Man, these really these searches are really horrible. Kill process call. Well, right, do we care about graceful exits? We don't, so might as well send a signal to it. So when the parent is done, just tell the child, you know, shoot, it's done, go away. Let's see, let's put an int exit code here. Exit code. code. Right, so when the parent is done, rather than just exit, I'm gonna set exit code here, and what I'm gonna do is do that. So PID. Ooh, now that's interesting because we don't have the PID of the child process, don't we? Oh yeah, we do, because why would it return our own process ID? I think it returns the child's process ID, doesn't it? Return value is, yeah, the child's process ID, of course. So we should be able to do that. And let's set it to do here. Do a graceful termination with sig term plus wait and then sig kill. Right, let's do that. Parent, and the child never even got to print anything. So what I want to do here is put like a, what is that called? Usleep, isn't it? Let's see, sleep. Oh, there's nano sleep and sleep. I'm gonna, this is a utility, this is a function. That's what I want. Sleep and unsigned amount of seconds. So 5. And yeah, it's done. You set instead of just printing that, I want to print, let's print the current time, really. Let me include time.h. And that's gonna be a problem because we need to pass null here. Great. Let's do it for 5 seconds, and well, that's awful. Let's do it as one line. So 1, 2, 3, 4, 5, and then that's that. It's gone. Everything works, and that's really great. So far, you know, first time doing this, it's going much better than I'd expect. But also, it's 1 hour into this live stream and nothing is done yet. So that's quite the problem. What to do? Let's put this command up somewhere else. Define commands. Right, that should work. Yep, everything works. Perfect. And of course that's a problem. Right, so we spawned the task. Let me check if there's any like tshark instances that stayed behind. No, that's great. So it cleans up after itself. Which is good. I barely do that. So we really want to do like a select call here to see either select or poll to see if the what is it? If there's any output from tshark. Let's do that. I think since either we're gonna have only tshark or tshark and like one pipe to read from, I'm just gonna use select because, you know, No need to go like all high performance if you're never gonna use that. You're never gonna need that because you only ever check like one file descriptor. So there's that. So how do you use selects? Number, and then you just give it to 1, 2, 3, 3 arrays and a timeout. That's good. And how do you make these arrays? Well, FD sets, select example C. Let's see. Cool, that's not really an example. Oh god. So you just make it as fd underscore set, and it can be a stack variable, I guess. That's good. So fd sets, so read sets. Do we care about writable stuff? We don't. Let's do the timeout as well. So struct time while CV and CV. Let's do like a 1 second again. 1 second timeout should be good. Let's zero initialize all of this. Cool. That's gonna run for 5 seconds, whatever. Right, what do I want here? What I want is fd. First, I'm gonna zero out the file descriptor sets, and then I'm gonna. How do you get file descriptor from file pointer? That's also something I'd love to know. fd sets, that needs to be a pointer, and whatever, 1. I'm gonna look it up. File descriptor from file C. So this is about getting file from file descriptor, which is fd open. The opposite is, it seems, file no. File no. Map stream pointer to file descriptor. That is exactly what I need. So int tshark fd is file no of tshark. While we're here, let's assert that tshark is not null. Could not spawn tshark. Cool. Right. So we do that, and then where is select? Let's get this up again. Select is here. So select returns an integer. Let's see. otherwise -1 shall be returned, and that's an error. So let's assert that. Select, and what we want is well, is that an integer? Let's see. It is an integer, so maybe a child function to wait until that. That might be better. That might be the better option. I could just loop that and then return. Right. Yeah, because how do you know which one's ready? So error, read, write. So you give pointers to that. And when it's done, it modifies them, and the ones that are ready are sets. And there should be like an FD check, I guess, is set. Yeah, that's the one. Right. So that means every time we need to add that to the loop, and then if it's ready, we'll just check with is sets. And there's that. So let's just move these bad boys into the loop and then call that is not -1. Let's assert. And number of file descriptors is 1 for now, but it might go to 2 later. This is really like a nothing. Just a blocking read. Well, we're gonna write it, I suppose. And well, wait right here. Oh, this is gonna be a bitch to handle. Well, I'm gonna do my best anyway. So set these two to null and give it that timeout thing, and then if fd is set and tshark fd and okay, this means there is output to be read. So what I'll do is, first of all, let's move the new line here, no new line here, and so we want to read from that, right? And specifically, we want to read a float and a string. If we don't handle that and call select again, I think it will just immediately return. So let's set that to like 10. So what I want is like f scan f, right? Yeah, exactly. So f scan f from tshark, and the format's gonna be like float, and what does it put there? Like tshark? No, tshark. Right. I think that's like a tab. So let's put the same thing here ourselves, and then it's like, let's say ints. Okay, cool. So we're gonna need those for TS and whatever packet length. TS and packet length. God damn it. Oh, come on. And I'm going to just put those here. Let's try. So that's an error because I think it wants a pointer to the time value, and it wants that to be a pointer also. So we could not spawn tshark, and that's because we don't have the spaces that we need here and here. That's reading something. It managed to read like one timestamp, and that was even wrong. I feel like. So let's see, why did that fail? Right, we do that. Oh, it's readable. Let's read it. Whatever. It's not even printing like a single new line here. It fails because it cannot start it. But why? Readable. The file descriptor in the calling process should be the readable end. That's what it is. Pipe streams are byte oriented. Whatever, it doesn't. Okay, I need to check stupid error no and turn it into a string. Okay, it's gonna be mode is invalid, no. Huh. I don't actually know why this might be failing. Let me just print the command here. Right, parents. Everything looks good on this part. So I don't know why it might be failing. Huh. That's interesting. T-shirt doesn't need root or anything. It does say capture started. So it runs. Oh, I'm checking if it's null. What the hell's wrong with me? There we go. Okay, so we're not failing immediately here, but it is also not writing anything to the output. Let's see, what is tshark writing to the outputs? Oh, it immediately writes like a lot. Right, do we need like an output file? Does it check W dash? We could try. Right, so what it's basically complaining like, oh, no, because when I pipe to cats, it just works. And the thing that has a problem here is from standard error. Okay, tshark file descriptor. I'd love to know what is the file descriptor here. So tshark fd is that. Well, it doesn't actually print anything, which is interesting. So it might not be reaching this popen. Okay, that's really weird. It's supposed to run like in parallel, isn't it? Creates a pipe. After popen, both the parent and child shall be capable of executing independently before either terminates. You say that, but I cannot see my output here at all. Yep. In fact, I see no output at all from the child process. Well, it is able to print all the way up to here, but right after popen, it cannot. And I don't know if that's because it simply doesn't execute or something else. A stream open should be closed. Buffered reading. So it says that I should just be able to read from that, right? But I really can't. And that's not fun. Is like fscanf failing? It shouldn't be. That's really frustrating though. Well, we could try changing the command here a little. Find command, something like this, which should not run forever. So if it's gonna read anything, oh, implicit declaration of P open. Why? Oh. P open. That should be right there. God damn it. Ugh. Still doesn't know about popen, or claims not to know. Well, there's no equals here, that might be why. There we go. Right, like it doesn't work, but certainly some more progress than before. Does that work better? No. But tshark certainly runs, and let's make the timeout like 1 second. Redirects standard error to dev null. Let's get rid of that standard error and see if we output anything, or if the whole output comes from the child process itself. Right, there we go. We certainly print lines, but nothing is actually read here. That's because this is not a pointer, is it? Float pointer, it wants a double. Right. Should that be a double then? LF. So it is a float. I think it wants a pointer, right? It doesn't though. Ugh. Why? What if I get rid of this? Still not good. More like one word. So will that work better? What do you want from me? God damn it. FD is set. That's still not equals 0. Right, it still doesn't work. Well, that might be... Oh, god damn it, just work. Let's print like something, anything. Okay. So according to select, it's never readable, or I perhaps pass it to like write FDs or something. No, that's really read FDs. I'm putting it in the right place. Read FDs. Being ready to read. Why is the descriptor set to null? Okay, well, that should work. Well, this really sucks. So scanf takes a pointer, right? And the input here can have these. So that's like a float and a number. Is like UD unsigned integer. But it's not. Why is it like that? Float, and then you just get a pointer to it. Well, the main issue isn't fscanf though, it's really fd is sets, which is never getting set. Fd set adds the file descriptor. Right. Tshark FD, right, that should work. Wait, sets. God damn it. Select example C. That's exactly the same thing I have. Two. Okay. Oh no. Oh. Did I seriously miss that? I really hope they never mentioned this. The range. Oh no, what have I done? Oh god. It's not one. Ah, damn it. Now it'll work, right? Nope, it won't. Because why would it? First, NFDS descriptors 0 through NFDS -1 shall be examined. Right. That's fine though. What is P selects versus selects? It's still not working. Wait, ISO output there. Oh, nice. It actually worked. How about that? Cool. Very, very nice. Okay, we have that. That's good. So what I'm gonna do is ist total, right? That's gonna start from 0. TS is like that. Let's see, we're gonna want to keep the last timestamp, or rather the last interval that we processed in that timestamp. Right, float TS, well, float lost TS. So if we read that, that worked, and if, let's set both of these to 0 first of all. So if the timestamp we just read is greater than last TS plus interval, then we're gonna set last TS to TS and print the total that we read in this period, which should be the total, and then reset total back to 0. Otherwise, well, reset total to packet length, and otherwise total plus equals the packet length, of course. And there we go. So it should print like every second, kinda. 2, 3. Cool. So we're doing like a 500K network traffic each second. I'm gonna do it for, let's say, 60 seconds. I really don't need it to go forever. Let's see. A byte to kilobyte, right? Divide by 1000, of course, of course. 0f. Right, so it looks like about 400 to whatever, this many kilobytes per second. Now the thing I actually wanted to try with this project is, what if I open a speed test while doing this? It should just shoot up. Ooh. No, that looks perfect. And then it should go down again. Great, lovely. So this is all the output we really need from the network capture side of things. And the other thing is sending this through a pipe to the main thread and then using SDL to plot it. So let me just take a break, see how tired I am, see if I want to do that part today or maybe leave it for tomorrow. Be right back. Right, I decided to do that part today as well because this project is just so fun. I'm lying, of course I didn't decide that. I asked my wife if I could, because otherwise I might not make it out for the next one. So let's look up SDL tutorial. That'll be fun. Yeah. Okay, I remember I used this website before. Right. Hello SDL, huh? Hello indeed. Cool. How do I get a window up? Okay, might split this up a little later. For now, let's get it working, and then later let's make it beautiful. That's the right way. Cool. So what I want is I just noticed something. Let's make this thing go fast. Why not? Let's optimize this, right? And of course all of these functions are static because, you know, this is not a library. We're not exporting anything. And if possible, they should be optimized. Let's install STL2. Well, it was already installed, so I think I messed up. Let's see, package config, right? And STL2, STL2. Damn. dash dash list all. Grep STL. There is STL too. I think the problem is I need to do libs. Okay, so there we go, and then includes, is it? Not includes. Then what? So we do libs and then, oh, C flags, of course. Libs and C flags. Nice. So that's really all I want. So let's put that in our makefile. So libs is that. Is that allowed? Whoops. Ah, crap. Oh, it's still not there because we didn't include libs here. Bam. That's not right. And that is because I did it wrong. No, that worked. It's still printing network usage, whatever. We're not going to read that right now. So, I really had like terrible audio in the previous streams. That was in the form of like really quiet microphone and really loud background music. I'm hoping this one mitigated this. This is what I said last video as well, but you know, what can you do sometimes? I'm afraid on this one the microphone might be a little too loud, but I'm scared to touch it because I don't want it to be like super duper quiet. But I'm just gonna touch it like a tiny bit because I see that it keeps hitting into the reds in OBS, which is, I mean, it's like a universal sign of like bad. No, it's red, don't. You know. But yeah, what else? Let's, I guess, make a STL to window. Oops. Damn. Right, create window. Right. Let's try. So we do STL init. Okay. Asserts greater than or equal to 0. Unable to initialize STL. Let's just add a function to check STL errors, right? Static void STL check. And it takes let me just go right there. Still init. Still init. What does it return? What does it return? Int. Really? Just ints. Return code. It's not a return code. Just value. Let's call it value. So we are going to do if value less than 0. False here, and we are also going to print puts STL error and also puts STL get error. And now instead of assert here, we should be able to do STL check and just do it like this. And in the parents, let me just do a create window and whoops. Right, let's try that. So no error from STL inits, that's nice. So we initialized, right? Now let's do that. What does that return? STL creates window, no. What was it? There was a STL call, right? STL call. That'll show us, and create window returns an STL window pointer. That's good to know. So STL window, so that's good. And then we do window equals that, and then we assert that window is not null. Otherwise we print could not create window. Cool. Screen sizes. Oh, there's only one good option. It's 800 by 600. You know, if you've used Windows XP, that should be familiar. That's the standard resolution. Wink, wink. Where is my window? God damn it. My window should be here. It is created, of course. Well, I never destroy the window. And I do call create window, don't I? So how come it's not creating the window for me? Or has it already created one? It really hasn't. Right, static void, create window, we init, and then we do that. Whatever. Window is created. It should be created. Can I printf like the pointer window pointer? Because I really want to see, right? There is a window pointer. So I'm wondering why it's, well, why it cannot display anything, right? Oh shit, I totally missed these messages. The stream is mature because I swear, and I don't know what Twitch thinks about that, and I'm not risking it because, you know, big company, trigger happy with bans, so that's that. How the fuck does this deal work? I don't want a YouTube tutorial. Also, I finally started using my second screen. So I can have Twitch chat here, and Well, everything else on the main screen, I guess. That's not good. Come on, just want to get a window up. How hard can it be? Oh, that's... God damn it. Still made easy. So video tutorial. Game tutorial. Sure. Sure, why not? Let's look at those. I just want to get a window up. Opening a window. There we go. I call STL create window, but nothing shows up. And he calls STL create window. And do I need to create render? Uh-huh. You know, we can always try. Right, window. What else? -1 for the first device. Let's try null for the third argument. I still don't see a window. That's sad. Window flags is 0 up there. Still window shown. Just show something. Why? STL is pain. STL is pain. Right, we create a window, 100, 100, whatever, STL window shown. Pointer will be null. So like the second I call this, a window should just pop up, shouldn't it? Because I'm not like destroying it anywhere, right? So I expect that, you know, it'll stick around. Handle parent. Like parent is here, puts window created, right? Let's try that. It says window created. I don't see it anywhere. It's not null because then our assertion would blow up. And I really don't know. Could try. 800. Is it like popping up on the second screen, I wonder? It's not. Not on the first screen. Not on any screen as far as I can tell. Render presents. Is it like that? Is it something like that? I init video, right? Yeah, I do. Okay. Let's look at other STL apps that definitely pop up a window, right? This is a GLFW, so that's no good. Let's try that. Okay, so we start, right? So let's find main. Oh, main is right here. STL init, STL init video, create window. Okay, well, is that all? Do I need like 00 instead of undefined? Is that what's messing me up? Window? Window anyone? Does anyone see a window? Because I sure don't. God damn it. Is window shown? Messing it up for me. Let's make it resizable. Right. No window still. Damn. Oh, is it like a fucking Wayland problem? Still 2 Waylands. But it should at least give an error, right? Should, right? Right. You in it, you create the window. Everyone passes like window shown. Oh, come on, just work, please. Damn it. Right, create window, hidden. I hate it. What do I need? Render. Window flags. Let's check that, I guess. Full screen. OpenGL, Vulkan. Create window. Come on, SDL. Be a little helpful. It's not like a high DPI problem, I hope. The window is open, right? Do I need like SDL poll events? Poll events. Oh, damn it. Right. What is it? SDL event, right? Events. Maybe it doesn't show up until you poll events, but doesn't look like that's the case. Let's do that in a while loop. Sleep 1 as well. I'm polling for events, and there are none. Doesn't. Ah, damn. That's still running. I hate that. Is tshark still running? I hate that also. Main. Right, time to go. Whoops. Time to go away. You cool, that's gone. Oh, damn. I got rid of that stuff. Window created. Everything should be good, but nothing is. Ooh, damn! I really had that running in the background, didn't I? That's terrible. Right, we got the what I thought would be the more difficult part of this thing done. That returns like a window pointer, right? Yeah, it should. Sets video mode. Oh, still creates window does not show window. Let's see if we can find other people with this problem. Still window does not show. Well, it's really like from 2016. Cannot be a bug, can it? It says you need the event loop here. Huh. Main thread, STL delay, holds it, just blocks the thread. Huh. Well, okay. STL delay. Let's put that 100 milliseconds of delay. That does nothing. I think I need to like poll for events and stuff, right? So for size ti equals 0, I less than 5, I plus plus. Let's do like 10. And the still delay for like 100 milliseconds in between everything for elliptic directions. Okay, let's do that. See if a window pops up. Seriously, nothing? That's terrible. Let's add Waylands to our query, and no window show up on Western. Unless something is drawn, like using STL create render. Damn it. STL create render. Window, nice one. 0. Well, I created the renderer. Create window, show window. render, create render. Is that the case? Seriously, STL renderer. Okay. It actually, oh, damn, you have to draw on the renderer in order to make the window pop up. What a terrible way to handle this. God damn it. STL draw rect, I think, is the next thing I want. Nope. Damn. STL draw. No. Rect. No. Well, STL rect is definitely a thing. So there's gotta be one where it's the parameter. STL render, right? Let's get some context here of like 5 lines. Come on, STL render. Surface, no, I want to render. I want to draw a rectangle. Damn it, need more context there. Let's put like a pointer afterwards. This should cut down on false positives, and I just want to put fucking pixels on the face, on the screen. But this documentation is really not helpful. Thank you, Rebel Elder, for the follow. This literally never happens, so yay. I will toast to you. Okay. But still doesn't help me draw a rectangle on the screen. Oh, the thing I want to do is so simple too. Render draw line, render draw, serious? Render draw, oh, look at all these. Render draw rectangle, love it. So let's get more context and let's look into that. 10 lines of context should be plenty. Okay, STL render. There should be like a render set color, right? Or set render draw color, right? That's good. Right. So render. So we set color. We set rectangle. And every time we read the value from the other thread, we're gonna push one, pop one from the top, or rather like something like a ring buffer, I suppose. Although we could handle both ways. And then draw the rectangles. So let's start by making a draw rect function or something like that. Static void draw rect. And I'm gonna read like uint 8t. Right, we should have global window and render, I think, just so we could do these things from various functions. So let me just move these things up. Damn it. There. So anything from here we can mark as STL stuffs, right? Why not? So of course the STL global variables should also be here, marked static, of course. Now static void sets color, right? Uint 8t r, uint 8t g, and uint 8t b. So this is gonna take an RGB color, and what is it gonna do? It's gonna do STL, oops, set render draw color with these, the global renderer and RGB and 255. We are gonna do that, and let's also do a void fill rect. That's gonna take a, let's see, what is STL rect anyway? I think it's just XY with height, right? Yep, and these are all ints. So int x, int y, int width, int height, and what are we gonna do? STL rect, right, x is x, y is y. We don't need to do it like that, do we? We could just do like this. How is the syntax? I always forget. Cool. And STL render draw. What was it? Render draw? Render draw rects. Takes a renderer and takes a rectangle. So that's good. So after we clear that, let's try to set color to RGB, right? Like a greenish color, and then draw fill rect, right? Something like 2020. That failed because, well, because that's a really new function and I totally forgot. So this is what I want. STL rect it once. Okay, so there's one issue. And I think it wants a pointer to it. That's that. It's not filled. Do you see that? Right here, it drew like an outline of the rectangle, but I really expected it to be filled. So, there should be like something like render, draw rect, fill rect, not draw. Let's try that. And now it's filled. We are one step closer to a real-time graph. That's cool. Now, two things I want to do. The first step is we want to get things from the child threads, which is running tshark and capturing all the output and aggregating it inside intervals. We just send those size t's, so send those 64-bit values to the main thread, and the main thread is gonna handle SDL events, and it is going to attempt to read from that thread, and if it's successful, it's just gonna put that on the array, and then the graph is gonna be drawn. So what can we do? Let's start by getting a graph up. So that's gonna be static void draw graph, right? Should we interpolate or not? We could. That's interesting. So size t and array, right? That's gotta be samples and size t, number of samples. So we have the window width, right? So that's hard coded to 800, and what we're gonna do is size t w rect width is 800 divided by what? Number of samples, of course, and size ti, so 4. Let's go over all the samples, and what we're gonna do is first of all set color, right, to 100, 200, 100, that's greenish color, and fill rectangle from I times the rectangle width, y can be 0, and then the width is of course going to be rectangle width, and the height is going to be the screen height. Let's try. Well, we never actually called that function, so let's try that. Samples, right? So I want it to be like a pyramid. Let's say 1, 2, 3, 4, 5, 4, 3, 2, 1, and then like a drastic jump to like 3, 6. What did I call that function? Draw a graph. Let's call that with our samples and size of samples divided by size of size t. And everything is filled with green. That's not what I was hoping for. Ooh, right, we're gonna need to do some mapping, because now we draw everything as full height, but okay, first of all, let's try it like this. If I draw it by sample, right, that's really not nice. Right, it gets a seg fault. Oh, the other thread keeps going. That's really not nice. So the first thread, if the main thread seg faults, the other thread is gonna keep trying to send stuff. Right, well, that's fine, I guess. We shouldn't be seg faulting anyway. I'm passing this by value, whereas I should be passing it by... Oh, no. That's the problem. Nice. So it's upside down. First issue is that our graph is upside down. Oh my god. It's never gonna go away, is it? Oh, balls. Okay, tshark. But is that truly gone? Let's filter by main. And let's just send a sig kill that way. And another one apparently that way. Now we are free. So this part is easy. That's just gonna be 600 minus samples. So it's gonna be from 600 to 600 minus samples. Let's see if that works. Does not work. Crap. Okay. That's fine. So when I drew it from 0 to height, it went like... Yeah, when I drew from 0, it was like that. So if I do the opposite now, and draw from 600 to... Oh, just takes a height. No need to do that, right? That's still wrong. I know. Gotta draw from 600 minus samples I to samples I. That should work much better. There we go. Our graph is back at the bottom. Now let's scale that up a little. Like every sample should be like 8 times taller. And now our graph looks much better. But of course, I need the scaling to be like maximum should be really like at the top, and so on. So let's get a map function, right? I should have one in my is there like util there? Min, max, clamp, mod. Where's map? Oh, that's bullshit. I thought I had map here. Map. I did not. Well, nope. Alright. Map. Whoa. Const export. Oh, I had that. Just in another project. Let's just grab it from there. Well, you are C++, but I can work with that. Damn it. So you are gonna be size T. It's gonna be size T based, right? Let's do it like that. Oh, damn it. It takes, of course, 2 things. Right, that's fine. I can work with that. Right, size T. And these can also be size T. Map. Let's just call it map size T. This is of course static. Cool. So what we want here is to get a max value of this array. So size the max value equals 0, and then let's iterate through all the samples. Num samples. If samples I is greater than max value, then max value is samples I. That's that. Right. So now we have the max value. What I want is to map that. To size the height, right? And height is map size t samples I from 0 and max value to 0 and 600. And that's gotta be height and height here as well. There we go. Our graph is now automatically scaled up to the maximum value. If you imagine that as like a scrolling graph, once that maximum value goes, everything else should scale automatically, so that's all good. Now, the difficult thing to do is to handle incoming data from the second task, right? We could really polish that up a little, right? Create window, network usage graph, right? 800, 600. Let's get rid of this delay. See if it still works. It works. Pops up even faster now. I can get rid of that. So render is there. Right, should have should have something to like a helper function that checks a single file descriptor with a timeout, or even without. Yeah, let's do that for sure. Static bool check readable. So if select does not have a valid timeout, what does it do? It should not be a none of the if the specified time interval. If timeout parameter is not a null pointer, it specifies a timeout essentially. If it is a null pointer, it will block indefinitely. So I want a thing, but I want it to be 0 seconds. Cool. I can do that. So we have that. And let's do an assert select. Let's do these. Why not? Cool, that's done. FD plus 1. Give it the readable sets. Null, null, and timeout. And then return FD is set. FD readable set is not 0. So we should be able to check if something is ready to read now. Right, here's the other thing that I want to do. I want to, after I create the channel, I want that to be global. So static channel, and this channel is gonna handle reading and writing the, what is that? Okay, usage, and it's usage channel, right. Let's have that be a pointer. So, in our parents is starting. Before we even create the window, before we even fork into a second child, actually. Oh, we create the channel right here. So, what I want is, right, we don't malloc that, do we? We don't. Can I set that by value by any chance? Let's attempt. No, usage channel is channel creates. tshark FT is undeclared. Why is that? Well, that's an easy fix. Done. Cool. We have our fake graph again, but it shall soon be a real graph. Right, create window. Cool, so we create that, right? Let's move that. Ooh, that's not nice. Right, that's really gonna be in a right, so we created the window. Let's put a loop here, but instead of a for loop, let's put a while loop. And instead of sleeping for 60 seconds, let us, well, handle quitting. So, quit. How do we quit? Right, poll events. If event type is quit, then we quit, I guess. Sure, we can do that. We poll events. If event type is SDL quit, then we quit. So we return. And that should clean up everything. Samples is undeclared. Well, of course it is. Let me grab that. Put that right there. Now EV, the event, is undeclared. Well, that is also an easy fix. Now we have that. And our window is there. We're capturing network data in the second thread. Everything works. If we close that, no, escape, no, nothing. Oh, that's not nice. So, essentially, the second thread quits. Am I doing something wrong here? Because I can't quit this, right? Let's filter by main again. That task is going bye-bye with a sig kill. Cool. But what I want to know is I did return, which should have gone out and killed the fork, but not itself. No, that's really weird. Still quits. Is it like a full uppercase kind of? Yep, that's the issue. STL quits probably a function, and therefore it was never equal. There. Escape. Q. No. Ah, now we can quit. Cool. Quitting works. That's cool. Probably don't need a delay, but let's keep it. Let's put a to do here. To do, see if we can remove this. Right. Let's see that indeed. Need some more monster. Right. We draw the graph, right? Here, in every iteration, essentially, we could check if... What did I call that? Check readable, I think, right? Check readable, yep. So, if check readable, net usage channel reads, read FD. Let me just go up and check. It is read FD, right? If there is some data to read, well, I guess we should read it. And man3 reads. Right, it takes a file descriptor, buffer, number of bytes, and that's that. So file descriptor is, of course, the net usage channel read file descriptor. And just gonna read that into sample, and it's gonna be, of course, a size of sample. Now let's see. Mem copy, right? Now let's do it with a loop. Size ti, right? I is 0. We don't want that though. Yeah, we want that. I is less than size of samples divided by size of size t, and -1. And samples I equals samples I plus plus. No, not that. I plus 1. We do that. And afterwards, samples I. That really sucks. I read that. I plus 1 is a sample. Will this work now? No. I fucking hate segfolds with this because it just leaves stuff running. God damn it. You know what? I'm just gonna leave that. Yep, that's good. No, it could not check if the thing was readable or not. I believe. Yeah, that failed because we do start selects, and we are supposed to do if that is not equal to -1. That works. So now, because there is nothing to read, the graph's not moving, and because we're also never writing anything. So instead of just printing here, let me also write to net usage channel write fd the total, which is size of total bytes. Oh, now would you look at that? That's pretty epic. Though I feel like it's not scaling quite right. Oop. And why would that be? Well, every time we draw the graph, we get the max value. Oh, we need to get the min value as well, don't we? If samples I is less than min value, let's set min value to like a really large value. Well, that's not right. C max size t. That should tell us. Oh, don't worry at all. Just handle your children. The VOD will be on the channel, and I'll also put it on my YouTube channel as well, which should be visible on the Twitch profile, I think. Let me see if I can grab that. I don't even have the URL memorized, so I'm just gonna have to go grab that. Where do other people find this? Like, honestly, Twitch is supposed to make this easy to find, but Twitch, there is no YouTube link on Twitch. Ah, I thought there was. Well, let me make a mental note to add that, but if you can't catch the VOD later, it should be on this channel at some point in the future, but no guarantees. It's just like open source. Size max, uint max. What about size t max? is T max. Is it just size max? Because if so, I'm happy. Yeah, there we go, that works. Min value is samples I. So now we should have a min value. And we're mapping samples I from min value to max value. And mapping that to 0 to 600s. That still looks really bad. And a sec fault, huh? Cool. Now, where is this all going wrong? Height, 600 in height. Ugh, damn it. Floating point exception, though. That's really bizarre. I am going to do if height greater than or equal to 600, height is 599. Let's do that. See if it fixes our problem. That doesn't look like it fixed our problem, not in the slightest. And it's still segfaults. So it might be time to whip out the debugger here. So okay, compiled, GDB, main, run. Right, that's a lot of threads. God damn. Is that all STL's doing? Okay, we got the floating point exception here on map size T. But we don't even use floats. Oh, we're probably dividing by 0. T1 minus F1. Okay, you need to go away, man. Right. That's not it, surprisingly. Oh, damn it. What did GDB call that then? Because now GDB is gone, but the main file is still there. Is it like something with GDB in it? Temp? No. Ah, damn. Where is that? Oh, that's so annoying. Let me switch that to like a tree and start collapsing stuff. Not you. Not you. Not you. Not you. No, 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 no. Not you. Definitely not you. Aha! It's you. Okay, my filter here is just Okay, that should be fixed now. And I believe we're doing like a divide by 0 here, right? I can't even see it because of the... Alright, so we're dividing something by t1 minus f1, which is 6 minus 6. And that's not right. Right. And in order to not do that, we can do like a if t1 is equal to f1, return, well, t2, I guess, I really don't know. Fast and LTO. Let's try that again. Okay. Right. So far, so good. But I feel like it's still putting everything on maximum. Yeah. Yep. That's not nice. But let's try a quick speed test. It doesn't help. Not in the graph, at least. Right, that does not help because I need everything to be floats, don't I? Yep. I would really like all of these to be floats. Floats. All of you are floats now. No, it's just putting everything on max. 2, 3, 4. How many parameters? Well, that's D actually. Well, I don't know. 1, 2, 3. So it's 5 essentially. 3, 4, 5. Value F1, C1, F2, C2. Right. 5, 4, 3. Cool. That's not mapping anything with the maximum. It thinks the maximum's 600. No, wait, something's wrong here. When we map, we're doing something very wrong. So it's from min to max. Is it not? So here something must be bigger than 0 and less than size max. But for some reason everything happens to be 6. That's not right. That's fine. That's totally fine. I want to print F. The samples here. God damn it. Wait. All the samples come as 6. Ooh, that's not right. I plus 1. about this? Perfect. This is pretty good. That's great. That's perfect. Printf. I can keep that. Remove that. Remove that. And nothing else. Right. So we are plotting this. That's fine. Cool. So that's a network plot, right? You run a speed test. Everything else gets buried. You stop the speed test, and we drop back to 0. This means my stream is like using pretty much nothing. Like 3,000 kilobits per second is what Twitch claims, but I don't know. Two things I want to do. First off, I want to do width 800, height is 600, right? I want to fix these. Height -1. That's the height. That's the height, and that's the width, and that's the width. So now it should be possible to resize this whole thing. For example, instead of 800, let's do 1000s, right? That works. Cool. The second thing I would like to do is where's that samples array? There. I want to keep more samples. 4096. Why not? And 0 initialize this. So now it should be like much higher resolution. Though it's drawing pretty much nothing. Alright. That's fine. But why? Did we overflow the stack? Possibly. 24. Let's do 24 of them. Yeah, the stack was like bad. Calloc. How do we calloc? Number of members and size of one member. So 4096 member, let's do 256, and size of size T, I guess. It's 256. There we go. That's not right. Something's very wrong. And what is wrong here? Well, that is wrong. -1. Cool. That worked. So now that's much higher resolution. That's fine. That's fine. Number of samples is... No, that looks bad. That looks real bad. There's like some 800 left somewhere, isn't there? Oh. Let's see. I'm sure there is. 800. No. There is not. Ah. Well, that's kind of interesting. Like, why would it start from there? Is what I'm trying to understand. Because that feels like instead of 800s, sorry, instead of 1000, it's 800, right? Isn't it? No, even 800 isn't quite fit. Huh. Does that need to be float as well? That doesn't help at all. That's awful. Well, let's look at something else first. Let's see if we can set the interval to like 0.1 and have it essentially be 10 times faster. Oh, don't need that. Forgot. That's perfect. That's pretty good. Quick speed test. Nice. See that auto scaling at the bottom. Oh, it's so perfect. Great. No. Two things left to worry about, essentially. We could interpolate a little, that's not the problem. But I want it to really use like the full width of everything. Oh, it's gonna like jump up so fast. Yep, alright, that's fine though. 1000 by 800, let's say. That would be much higher resolution for me, and I would enjoy that quite a bit. Come on, it's like one tiny issue left, just make it work. Okay, so the problem is why it starts like right in the middle here and doesn't go ahead of that. So number of samples 200. Damn it. Is it too many samples? Is that the problem? Because I can make it. So 10. Okay. Define and sample. Okay. NS is 10. That's NS. It's gonna be NS minus 1. And that's gotta be NS again. So let's try with 10 and see if it can do anything. So 10 seems to draw pretty well, right? So let's gradually increase that. 50, right? 50's gotta work, right? And of course 50 works pretty well also. Right, 100. Does 100 work? 100 works perfectly. Let's do 512. And I think that's where we might start seeing issues. Yep. So, I believe this is about keeping stuff as floats rather than ends. So what if I set that as like a float? I suppose that would work. There we go. Okay. It's still not good. Still gets like some space in there. I don't like. So it needs to be evenly divide the width. So let's say I have 128 samples. 3, 10, 9, 8, 1024. So only 24 more pixels. And we will have no issues at all. That's perfect. That's great. Cool. Guess we can make that like 300. Oh, that's great. That's really lovely. Can we make it also that delay might be messing things up for us here. So let's do that. Ooh. That did not go well, did it? Damn. mean, this is pretty much done at this point. Now what I would like to do is STL delay. Is it possible to get rid of STL delay? Right. STL game loop. Let's see what other people do for this. This 3000 thing. Right. Going to screen. Render present. Okay. Wait for resync. Huh. Well, let's see. STL delay. Let's try that. Might be slightly better. I hate the fact that it buffers the output. Really don't like that. Could that be in any way related to me? Fscan F, right. Let me try it like that. I think we might have issues. Okay, 0.1. It's supposed to be 10 times a second, but it really is not. So that's fine. Let's do a quick speed test. Bam. Really nice. That worked well. Ooh, actually, why do I need that at all? Oh, that's totally unnecessary. To check these, just use blocking, right? I mean, we're using threads as our thing, right? Aren't we? So let's do that, I guess. Do that, do this, do that, and that's not good, that's great. Okay, we no longer need to have the overhead of select, and yes, that's pretty good. What is tshark delaying that? Let's see if it has anything to do with the buffer size. So dash B. 512. Let's try that. What about 5M? Huh? Okay, that does not help much, so I'd rather get rid of it. Right. Let's see. tshark. Buffer. Set capture buffer until that data can be written. tshark, no buffer. Dash no buffer. Oh, yes. Oh, that would be so sweet if that just works. Oh, that's not nice. tshark, dash T fields, right. Dash X, dash W, hosts file, 2-pass analysis. I don't need any of those. Huh. Maybe it has something to do with the ring buffer. So duration interval. Okay. Let's try duration 1 second. Right. That's the thing. Flash standard output after each packet dash L probably makes it line based. That's where the L comes from. Is that any better? I can't quite tell. Let me check here. That's that. What about dash L? Still a little buffery, not gonna lie. Fields. Buffer. Huh. All right. How about 0.5? So that's twice a second, right? That's like 4 times a second. That might be a little less noisy. That still has a little buffering there. Not the best. But sure, that works for me. I'm happy with this program. Just gonna set it to some ridiculously low number. Right, this is what happens. Still buffering, but once the buffer is, not bothering us anymore, we get to read a lot, which is nice. Let me comment that out. Right. Maybe standard output is delaying us a little, but it's really not. Yeah. I suppose this regular thing and then the tiny spike up there is probably OBS sending its big frame, and then the other ones are like the difference frames or whatever. You know what I mean? Right. Let's do a quick speed test, see how noisy this becomes. Right. Alright. Yep, that's fine. Could set like a maximum if you wanted, so the graph wouldn't jump around so much. But this is also very, very nice. Super good. Super duper good. Another thing was this thing here. Where is that? Yes, that's. Let me grab that. 128. Let's do 50 samples and 500 width. Should be much less noisy, so there's that. The speed test ended and it became like that. Perfect. Let's do 800. Let's make that 250, 800, and 80, I suppose. Or 100. That'll also work. No, 0.5 is a bit much. 0.3, let's try whatever we can get away without too much buffering. Will be good. Still buffers. Don't like that. Don't like that. Cool. That works. I'm really pleased by this. Didn't think it would be so nice. And I mean, it took a while, but I mean, come on, we had the network monitor part running like pretty quickly, and SDL, you know, wasted some time with that, but in the end, that was also really nice. So, no complaints here. Super fun projects. Let's see. Let me just pause my own music and open like a YouTube video from my channel and see if everything's good. So these small network requests are barely perceptible in my own network monitor. Let me just open this Thanos snap video real quick. We're playing video, bandwidth shut up. Let's go to a more active part of the video. You know. Doesn't matter. Let's get back to. Let's put the quality up a little. Let's make it 1080p. There we go. Now, of course, that spike up is like buffering, right? It buffers, so in the future it does not have to fetch so much data, right? But once it reaches like the end of its buffer, it will need to get some more. I can show that by like kinda skipping ahead. Yeah, as you can see, if I skip ahead a whole bunch, that also results in a lot more data being fetched. So yeah, this can actually give you some insights into network activity in your computer. And since that's tshark, you could theoretically pipe that over SSH and monitor network usage on your servers, although it would be better to do the aggregation there and then send the aggregated data for each interval. But yeah, in the end it just works fine without any issues. And yeah, I mean, it's a network graph. Don't know how accurate it is, but you know, I open a speed test, usage goes up a lot. I stop speed test, usage goes down. So there's that. Thanks. I think I'll be done. Might work on that project more, but it's essentially done. Some useful nice to haves would be maybe fixing the maximum and minimum values so the graph doesn't jump around as much. You could keep the automated one that's just based on min and max values, but you know, putting like a nice like 5 megabytes top, 0 bottom would make it easier to see some patterns as well, I bet. So that's something to investigate in the future. Like, yeah, there, just that jump is really jarring. Now you don't know, no context as to what you're looking at. I could try that, actually. Let's give it a go. That's really easy to do. So just the last thing I do before I end the stream. Min value is gonna be 0. And max value is gonna be what? 5 megabytes to bytes. So this should be a fixed graph now. To make the resolution slightly better, let me increase the height to 500. Right. Now, that's a slightly more useful one. And now, if I do a speed test, the things at the bottom, they won't go down more, just the speed test. Since it maxes my, I think, 10 megabytes or so connection, it just clips at the top. It says 80 megabits per second, probably because of streaming. But yeah, I mean, that works, right? That's way better than the other one. Maybe what we could do is, instead of keeping the max samples for the current samples, we could keep it for the whole session, which would, you know, essentially learn what is the max. You know, I kind of want to do that. Let's get max and min from the whole session instead of the current samples. So there's that. There's that. Make these bad boys static. And that should essentially have the same effects. Right? You could have like a calibration run, right? Just run a speed test. It hits peak of your network connection. And afterwards, the plot should be fairly accurate, like percentage. Like bottom is pretty much 0 if you have any time with 0 activity, and top will be what your network connection has achieved so far in the history of running this program. You could even persist that in a file, but that will make the live stream go even longer than it has until now, so I'm not gonna bother with that. But if you are following along, this is something you might want to do yourself. So that's that. Thanks everyone for watching. As I said, I'll try to put this on YouTube. Don't know how long that'll take, since that's like an absolutely massive live stream. But yeah, thanks everyone for watching. I'll see you on the next live video that I do, and I'll put the source code for this program in the description. I'll put it on like GitHub gist or something, or Pastebin, whatever. I'll put links in the description on both YouTube and Twitch, so you should be able to find that and compile it and run it yourself. Thanks everyone for watching. Yeah, I'll see you on the next stream. Bye.